Conics, the standard form of a hyperbola. A hyperbola is a type of conic section, which is a curve formed by the intersection of a plane and a double cone. We've learned about the circle, which is at the intersection at the top of the cone. We are really familiar with the parabola because of quadratic equations. We recently learned all about the ellipse. Now we're on to the last conic section, the hyperbola. The foci are points inside the hyperbola that help define its shape. Hyperbolas have asymptotes, which are straight lines that the hyperbola approaches but never intersects. You'll learn more about the foci and asymptotes in later lessons. For now, we'll focus on the equation. The standard form of a hyperbola centered at the origin in a Cartesian coordinate system is given by x squared over a squared minus y squared over b squared equals 1, or y squared over b squared minus x squared over a squared equals 1. Depending on whether the major axis of the hyperbola is along the x-axis or the y-axis, the equation takes on one of these two forms. A represents the distance from the origin to the vertices along the transverse axis, which is the major axis. B represents the distance from the origin to the vertices along the conjugate axis, which is the minor axis. The distance from the center to either vertex is A, and the distance from the center to either covertex is B. Here's an example of a standard form of an equation of a hyperbola. X squared over 3 squared minus y squared over 2 squared is equal to 1. We can simplify that to get x squared over 9 minus y squared over 4 is equal to 1. The center is at the origin, and here's what the graph looks like. So you may be wondering how the ellipse and hyperbola equations are different because they look so similar. The key difference lies in the sign between the terms involving x squared and y squared. In an ellipse, both terms have the same sign, either both positive or both negative. While in a hyperbola, the terms have opposite signs. This distinction determines the shape and orientation of the curves. Ellipses are closed curves that represent bounded shapes such as circles or ovals. Hyperbolas consist of two separate curves that extend indefinitely and do not close. They have two branches that asymptotically approach straight lines called asymptotes. The fundamental difference in the signs between the terms in the standard equations allows for the distinct geometric properties and behaviors that hyperbolas have. The path of communication satellites orbiting the Earth often follows a hyperbolic trajectory. Hyperbolic equations are used to predict and calculate positions of satellites in orbit, enabling reliable communication around the globe. This is just one example of hyperbolas in the real world. Hyperbolic navigation systems measure the difference in arrival times of signals between different stations, allowing the receiver to triangulate an exact position. Hyperbolic discounting is a psychological and economic concept that describes tendency for people to prefer smaller, immediate rewards over larger rewards that are delayed, but only up to a certain point in time. And we've got many more. Thank you so much.